Let me introduce Nikhil then. Nikhil is a research engineer at the Media Lab at the Center for Bits and Atoms with Professor Joe Jacobson. He is a co-founder of Osmocosm. He's been with us from the beginning. He is part of the magic that makes this happen. We're eternally thankful to him. And he's going to give you an overview of the various olfactory technologies from an engineer's standpoint. Please.
Thanks, Andres. Is it okay if I present to the screen? Yeah. It's not being recognized. Turn it off, turn it back on again, right? Yeah, great. Let's see. Hi, oh yeah, so it's great to be back for the second year. Good to see many new faces, great to see many old faces. My name is Nikhil, and you'll have to excuse me, I was boosted earlier today, so I'm feeling a little bit odd, but we'll give this our best shot. By trade, I am an electromechanical engineer. I spent the first half of my 20s figuring out how to build everything from 0 to 60, working at a massive multi-billion-dollar company. I spent the second half of my 20s working in epidemiology, building tiny sensors with tiny teams. And most importantly, at least at the conference, I am an olfaction enthusiast, like many of you. And today, I'm here to talk about standardization. And no, it's not as boring as it sounds. This is a really exciting time to be part of electronic noses. We're at this interesting cusp where over the past few years, we've become very accustomed to diagnostics. I think everyone's had a swab up their nose at least once or twice, I'm sure. And we've kind of seen that the user interfaces associated with diagnostic tools today just really aren't cutting it. They're uncomfortable. They're painful. And so I think a lot of us are realizing that, yeah, electronic noses have a lot to offer. And so I need not explain more about that. But what is really interesting is that we kind of are at this point where we have a first generation of working electronic noses. In my hand, I have this thing called the Nose, spelled with a Z, by this company called Standardization. Andres gave it to me in his office the other day. And it's clear that anyone can go and buy one of these highly comprehensive electronic noses with a variety of sensors within them that can be used to do simple things like monitor the presence of oxygen or CO2 in the room. This is kind of expected. This has been, as simple as your carbon monoxide alarm. But what this also offers, and it's sort of unique, is that it has like a COVID risk signal. Now, what's interesting about olfaction is that you can use it for medical diagnosis in the context of the FDA, but you can also use it in the context of risk numbers, saying, hey, maybe you should go get checked out. And this is maybe a loophole for now, but it's still open, and this device takes advantage of that. And so this is this exciting first generation nose. A few other ones we have up here are Aromix's Essence chip. This is a few years old photo. We have the Sierra Nose 320, which is this really great piece of tech, originally developed by JPL in the early 2000s. A few of the noses I built myself on the far right. The top right one is specifically for the detection of acetone to monitor the presence of ketosis based on your breath. And the one on the bottom right is a surface acoustic wave sensor, which can be used when functionalized to detect many different things, but at a very sensitive, very affordable way. And so this first generation nose is largely modeled after mammalian olfaction has sort of taken off. It's here. It's happening. And the signals emitted and the way we track that data is sort of, I would say, trivial. We've all seen a matrix full of linear data. We've had these devices. Anyone who spent like 10 minutes in pandas or data or used data frames in the past has said, okay, I have a matrix with some data in it. How can I interpret it? What signals am I getting? We can develop polar plots. We can do principal component analyses. And these things are all like sort of straightforward and intuitive. And I think the first generation of noses will all sort of follow this path. But here's what's happening. much like in evolution, where we had mammalian noses relying on a large array of olfactory receptors, evolution is happening and we've started moving towards these other methods, these spectroscopic methods. And so much in the way that our eyesight or our ability to hear has developed, so too we as humans are engineering new methods that have new data form outputs. In the case of GCMS, we look at things like, we separate out scents into different compounds based off of their mass, and then we split them apart and we count the number of different elements in a given signal. Ion mobility spectrometry, we measure the time it takes for a molecule at a different weight to move through a tube. Infrared spectroscopy, like Tunable was presenting on earlier, which is, for the record, an incredible technology they figured out. This is where you measure the rate of absorption of a given wavelength, and again in the terahertz range, so a slightly longer wavelength. Again, another absorption method. Raman it doesn't even matter what elements you have in the molecule. So this method is going to give you a waveform that's totally disparate from your existing elements. This waveform, it's fantastic, it's precise, it's well used in the material science field, but this is entirely dependent on the relative energy of the bonds in the molecule, or the order of those bonds. And so where do we go from here? And I think that's a question that I hope this conference would catalyze. It's how can we find a universal language, something where we can all talk and say, this scent represents such and such. I have some ideas up here I've grabbed from a website focused on compound analysis. And so one thing we can think about is like, does this scent have the lily and violet component? Or in the context of whiskey, or are these aldehydes or esters? Or if anyone who drinks coffee or wine knows the blueberry notes. Well, humans over the years have thought of many different conventions to easily kind of share how we feel or perceive a different scent. And so I wonder, is there a digital analog that we need to start thinking about so that one day when we do have scent information, when we have Osmo data and it's available for all, what is a way we can easily share that data and speak this universal language? And so that's kind of a question to the audience. So if people have ideas, please, I'm here for it. Thank you.
Thank you. Okay, questions for Nikhil?
And ideas.
And ideas, yeah. He wants to know how you would imagine a olfactory alphabet.
Yeah, factory alphabet, yeah.
Yeah.
We've been doing this for years. We just need to make it better.
Correct.
Standardized. Yeah.
So do we have questions from the audience? I think
yeah.
Let's see.
I mean, you're giving me all these flowers and whiskey and all that kind of stuff.
Yeah.
I mean, what about feelings and anxiety and things of that nature? I mean, why don't I see anything like that up there? Maybe isn't that something we should be looking at?
So you're saying, so there's a question, the way that it makes you feel or the way it makes other.
Well, let's not talk about me. But,
okay.
You're asking about can we detect those olfactorially?
Right.
We had speakers that talked
No, I understand.
anger and then anxiety.
Right.
Yeah.
So is that another slide you should probably incorporate, where you have the aromas, you have the chemistry of alcohol, but now what about the olfactory data for anger and things like that? Isn't that something we should be looking at?
Yeah, I think, absolutely. And I wonder, do we limit it to our species? Are these scents that make like primates angry, or are these scents that make like dogs angry? And then so we have like the canine standard, perhaps. No, I think it's a great question.
It would help with the animal training too.
Almost certainly, yeah.
Yeah, last question because we have to move on.
Okay.
All right, yeah. So a quick thing with standardization is that there's like the difference between what compounds make up a smell versus how those smells are perceived, right? Two people can smell the same compound and have a different perception of what that smell is, if that makes sense. So how does that like play into a pure standardization for like, oh, this is what this smell is, when two people can't really.
No, that's actually that's a question that really gets at the core of the issue, mm-hmm. right? And thank you for that. No, so what's interesting is, I think Andres was the friend who first brought this to my attention, is that sense of difference between interspecies or intraspecies, their interpretation of a given smell, doesn't stop there. It's present in the electronic noses as well. For things as precise as a GCMS, which up until recently was sort of the gold standard in scent-based analysis, you can take identical benchtop instrument and you can compare it from one lab to the next, and the signals that are being output are quite distinct. And this is why we really need to drive towards an abstract representation of scent. And it doesn't have to have a name, but it would be fun if it was sort of easy to interpret and think about.